herd idea. Let's talk about that.
Okay.
Gene, on you.
So what we know about eliminating viruses, viruses require they're parasites and they require a host. That means some body, some human being to live in. And as long as they have people who are not immune, they're going to continue to propagate and go from one person to another. When you have enough people in our herd, HERD, because we're pack animals, human beings,
Hmm.
um, when you have enough people who have been exposed and are immune, then the virus has less of a population to invade, to infect, and it dies out. And that's what eliminates the virus. And it usually takes about 60% or two-thirds of the population to have it become immune for the virus to not have enough people left to actually thrive. So, what will likely happen, short of a vaccine, because a vaccine is kind of giving you immunity artificially, uh, the time it takes for us to have 60% of the population exposed is about what it's going to take to eliminate this virus. Now, the reason we're in isolation is because we want to spread that curve out. Because if we can only have a small number of people at a time getting it and becoming immune, it does a number of things. One is it doesn't overload the healthcare system, which is going to be completely swamped. Number two, the people who get it early and are tested. That's why testing is so important. If you know that you've had it and then you're realistically or hopefully immune, then you can be recycled back and you can take care of people who are sick and not get infected. So it's a matter of working with our population. We've never done this before. This is brand new. We are doing a controlled experiment, hopefully controlled, in which we're actually trying to figure out how we gradually let a number of people become exposed, infected, and then recycle them to become the new first responders while those who are ill, take a break. And that's going to take a number of months. It's not going to be a quick fix. And we don't want it to be a quick job because that will peak and it'll overwhelm the system.
Right. I mean, I want people to think about what does 60% of 300 plus million people mean? I mean, this is a huge number. We don't have the the hospital beds, the facilities to care for that many people all at once. Over time, we do, and we can help by taking care of each other. This is part of being a social animal, and this is part of
Right.
why we really need to listen. Semmelweis had it right, and no one believed him then. Let's not make that same mistake again.
Yeah.
Can I
I, I,
ask
t-
a question, Dr. Joe? Just for clarity, Dr. Beresin, you said the testing is very important, and I
yes.
understand that. But my understanding was that when you're tested, you're being tested whether you have it at that moment in time.
Right.
Did you
That's right.
say that you can actually test it and find out that you had it in the past and you're
No,
now in and
I,
out of it?
I
Like,
don't believe.
is
I
that
don't. No, I
it?
don't believe you. The testing is really only when you have it. So I think what we need to do is when people are symptomatic, uh, when they have a cough, when they have a fever, when they have a sore throat, they should be tested. If you test positive, then you know that you're one of the people who will go through whatever you're going through with the illness, and then potentially be immune so that you could go back out and help others. Um, so testing people when it's over, I mean, that's going to require means that we just can't do. I mean, you're going to have to look at their plasma and their antibody levels, and that's too much to impose on the population.
But are you saying that if they are tested positive at one point in time, they're immune? They can't get it a second time? Because
Well,
I
we
heard
don't we don't know for we don't know for sure. I mean, what most of the experts are saying is, if this coronavirus, which is it's the same virus, it's a different strain, but it produces the common cold. And for each strain of a virus that we know of, um, in this category, there has been shown to be immunity. Now we don't know whether this particular strain, but um, once we if we assume that that's the case, and if scientists find out that it does in fact produce immunity by looking at the blood, the plasma of people who have had it, and they see that they're antibodies, then we know that, That's going to take a little bit of time to actually know whether the immunity develops.
So,
Yeah.
but there's been enough people that have had it that they can start testing plasma and such, right?
They absolutely can.
But it takes a while to
And
determine.
in fact, one of the treatments that's been used in China and then now is starting in this country is using the plasma of individuals who've had it, who have the antibodies, to give that to people who are sick, and that helps them fight the illness.
Because they're getting an influx of the antibody, not the actual virus.
That's right. Because what happens? So for people that don't know what an antibody is, the virus is the antigen. Technically it's the virus comes in, and the immune system produces antibodies or proteins that actually attach to that virus and try to get rid of it. The more antibodies that are available, the more the body's able to eliminate, isolate the virus. And once the virus is all gone, the antibodies remain in the system, and that prevents you from getting infected again. And those same antibodies could potentially be used in other individuals to help them fight the illness.
So, how quickly can they figure this out?
I don't think anybody really knows that yet, Mark, because we're still in the early days. But just to bring it back to an IM, this is still an IM, folks. This is what the IM idea is about, is that we are always adapting to these 4 domains, and that it's not about whether you're sick and broken, whether there's a pathology, whether there's an illness. What really is happening is your biological domain is responding to the IM of something else, in this case, the coronavirus. The coronavirus has its own IM. It comes in and invades your home domain of your biological domain of your body and tries to take it over. And when it does that, your body says, wait a second, my place, my place. And it creates, as Gene says, these antibodies, these things that are chemicals that we produce that fight off that infection. And then what's cool about our body is we remember them. We remember those ways to fight that infection. So the next time that virus comes in with its own IM and tries to invade our biological domain of our home, our body says, no, we're going to do this a lot quicker. Boom. And we produce these antibodies and it just fights it off right away. So it can't get to that point where we necessarily feel sick. We're just fighting it without even realizing it. I'm pretty much right, Gene?
Yeah, that's exactly right. That's exactly right.
So, are you suggesting people test before they even start feeling symptomatic then, because they might be and they can?
Well, that's a very good point, because what we know is that if you're exposed, the incubation period, or the time that the virus is producing and reproducing itself, is about 5.5 days, and about from the time of exposure, and it takes about 11.5 days for you to get symptoms. Between that 5.5 days and 11.5 days, or about a week, you could potentially be transmitting that virus. You don't have symptoms. If you've been exposed, that's one of the criteria for getting tested. So if you've been exposed to someone that has tested positive, you get a test, and if you're positive, then you go into isolation and until you've recovered. On the other hand, if you're symptomatic, if you've got a cough or a fever or a sore throat, you can get tested then, and then we'll also know. So there's 2 times to test. One is when you're before symptoms but exposed to somebody, and the second one is when you actually have symptoms.
Stretch the canvas, rush with madness. Is it sadness or just a show?